Um, yeah, thank you so much for everyone attending today. I extremely appreciate your coming to this event. We are also recording this so you can review the presentation, and we will send you the presentation as well for your attention. And now please let me introduce Dr. Dinos Constantinides, our distinguished speaker. It's a great pleasure to know him, and not only that, he is a world-renowned authority figure in the water utility and water supply management field. Brings with him over 4 decades of expertise and leadership in the development of advanced utility solutions, beginning with a Bachelor of Science and then graduating with a PhD in the water engineering in South Africa. He did groundbreaking research at the Hydrological Research Unit and Water Program as a senior research officer with roles at contractors like Morey and Roberts. And since 1987, he's a CEO and founder of Hydrocomp Enterprises. And under his leadership, they developed the Adams utility management software, which specializes on solutions for technical commercial operations across different sectors, focus on water and sanitation, municipal services, but also solar energy. And today, Hydrocomp is operating in the United States and with major operations in Egypt, South Africa, and over 20 countries, servicing over 30 million end customers, over 50 million end customers. And he's a practitioner in the field, but also a prolific researcher with having written 3 books and 70 publications on this issue, on the water asset management. And today we will cover an integrated approach to asset management for optimal business performance. Dr. Dinos will show key challenges faced by utilities, the importance of a comprehensive AM system, ISO standards for asset management, case studies from the water sanitation, and maybe some solar energy. And I'm very honored to have him, Dr. Constantinides, today, and to bring his wealth and knowledge. And following this, we're going to have a Q&A session, and I kindly invite you to please participate and bring your expertise to the table. And with that short intro, I invite you, Dr. Dinos, to please share your presentation. Thank you so much for being here.
Thank you, Volkmann. I'll share my screen. Now, this presentation has quite a lot of detail in it. I'm not going to go through each slide in detail. I've done it like this so you can have it as a reference after the presentation. You can read through the detail yourself. But I will stress the major points and to be able to stimulate discussion on what I feel are the important dominant issues right now facing the industry. Okay, that's the agenda. I'm just going to cover the scope, first of all, what industries we're talking about and what type of products, the challenges facing the utilities, how we understand asset management, a little bit about the standards. I'm not going to dwell too much into them, our approach to asset management, and then give you examples on integrated asset management systems for solar energy, water and sanitation, and municipalities. I'll focus more on the water and sanitation side. And then just a few words about case studies of what we've done, and a little bit at the end about the benefits from implementing such a thing. Start with a scope. That's the industries we're covering: water and sanitation, energy, municipalities. When we say municipalities, we mean all the type of services that a municipality should have as well, including electricity. And then government, environmental type of sections of the government. For example, as one country where we have implemented a full water management system according to the European Union regulations, which are quite strict. In terms of the software products that we have and they address this type of customers, we're talking basically all the software with the exception of the horizontal industry software like ERPs, exception of financials and stores and procurement and HR. So we cover the commercial and technical side of a utility in terms of billing and CRM, asset management, operations, licensing and permits, demand management, quality monitoring. And we have a pretty advanced utility business intelligence system to be able to cover all the information that the utility uses. Challenges, those are the main challenges facing utilities. Top ones basically apply to all utilities, the bottom ones more to water and sanitation. A poor asset register is very often a big problem. People sometimes do think that they have a good asset register. They even tell us, I've got 70 DMAs, and then we take the data, we convert it into IDEMs, and we tell them, no, you think you have 70 DMAs, you don't, you have 4. So you need a very intelligent system to be able to understand and manage your data, to be able to help you verify the data set you have there. If you don't have a good data set, everything goes wrong after that, being maintenance, being planning, being modeling, and so on. Aging infrastructure, which is a big issue in the US. I think over the years, the infrastructure has been neglected, especially water, and right now they're facing a big crisis and a big challenge with things packing up, and the amount of money required to be able to replace or even fix the existing infrastructure is so huge that the need is there to be able to prioritize, identify the high-risk elements and focus your money on that. And at the same time, implementing asset management to be able to extend the life span of your existing assets. Low productivity, also quite a big issue, can be addressed quite easily if you have a proper system in place, especially a lot of proper fieldwork systems linked into your main systems. Affordability is a big will some people said to me, yes, you talk about these systems and to put them all together, and it will cost us a fortune, we can't afford it. And when we're talking about countries like the US, where they have something like 50,000 water service providers and utilities, a lot of them are extremely small. So they can't afford to implement a proper asset management solution. And that's a big issue, that you have something for them that's affordable. Integration, the biggest problem, especially in the US. And I say why in the US, because in the US, you have this tendency that every single Tom, Dick, and Harry comes up with a piece of software or a solution, which is a little part of the big puzzle. And they all have their customers, and then the customer try and put things together, and it never works out. I had a guy who spoke to me last year, and it was in ACE 23 in Toronto, and he said to me, "Dino, I understand what you're doing." I said, "How do you understand?" He said to me, "I'm head of asset management of AWWA, and he had some very high position in Xylem." I said to him again, "Well, how do you understand?" He said to me, "Before this, I used to be town engineer for the city of Denver. And for 10 years, I tried to put together what you're saying you've got and it's running, and I didn't manage it." And I said, "Why?" He said to me, "Because I had to put all these different type of software together. And it was SAP, and it was ArcGIS, and it was Maximo, and it was this and that. And by the time I used to get the links right, and somebody changed the version and everything collapsed." So integration is a big issue, to have all the pieces of the puzzle. But the other biggest issue here is that people don't understand the amount of, especially people who make software or make solutions, like the big boys in the United States, which make all these fancy meters and they dominate the market. And they think just by getting some readings from the system, they have an asset management solution, or an MIS, as they call it. And they don't understand the complexity of the business processes that happen within a utility to be able to do service delivery. Unless you work in one of them, and thanks God we have in the panel a couple of people that don't work for utilities, and you see the day-to-day running and what happens there, you don't begin to understand. And the biggest problem right now is the understanding of goes on within a utility or a municipality, a service provider. And there are workflows required to be able to put this puzzle together to make it work. And this is the thing I'm going to focus on today. I'm going to show you how we understand it and how we put it all together. Okay, poor reporting, monitoring, evaluation, low revenue, a lot of commercial losses. Again, billing systems are a big issue. Keep on referring to the States because I have most of the audiences in the States. There again, we have this tendency over the years that they have what I call municipal billing. They have some sort of simple system that's part of a package, an ERP package, and they think that's probably billing. That's changing right now. A lot of people I see from tenders, they go to tenders saying that I've got this billing, which is, I won't mention names, one of the municipal billing, but I want to change it now to get a proper utility billing. So you really need the proper utility billing systems to be able to address proper commercial losses and make sure debt management is done right and all that. Leakage, you've all heard about leakage, energy losses, high electricity pumping costs. I'm not going to go into detail of that, but these are all issues that we faced over the years. I mean, just to give you an idea of high electricity pumping costs, very often when we opt to help customers optimize their networks, they have these networks and they have pumping and they think it's all nice. And then when you do hydraulic modeling and demand analysis and all that right, you get the assets right, and then you try and optimize the scene. You find so many things that are wrong. And we had many cases where we cut down electricity costs by 30 and 40% by rezoning and rearranging the pumping configuration. A lot of people don't know it's there, the problem, but it's there in a lot of the utilities. Okay, next slide, just understanding of asset management. Let's look at history. It all started with repair. Something broke down, people running to fix it. And then people thought, now they can do a little bit better than that. And they're going to look at the condition of the asset and start maintaining things based on condition. And then the last 10 years or so, they realized that condition is not good enough. They have to look at risk. And basically, risk is a combination of condition and importance. So basically, they introduced importance of the asset. into the equation, and they started doing some sort of reliability and risk-based analysis to be able to address. And that's where ISO standards are mostly relevant on. Our more recent approaches, however, have gone even further, and the recent definition which we've adopted is that asset management is an integrated approach to monitoring, operating, maintaining, upgrading, and disposing of assets cost effectively while maintaining a desired level of service and improving overall business performance. Now, those last parts of the sentence, of that sentence, basically changes everything, changes the ball game. It's not just maintenance. Now you have to look at the full life cycle management of assets. And basically, if you go into a utility, it's not the technical people involved, it's everybody. Everybody has to be involved in this whole process, even from the financial side, procurement side, maintenance, operations, condition assessment. If you want to go a step further, you can even introduce quality as part of it. And that's one area, again, where a lot of utilities suffer in terms of having proper quality monitoring systems to be able to look at trends and to look at geographical distribution, dispersants, and so on. One of the biggest challenge is money. And money is part of the equation where you have performance, risk, and money, where you're trying to balance all that. And, I think in the States until now, people said, we have lots of money. We're just going to put in money to give the performance we want. But now it's changing. That is changing as well with aging infrastructure. That's becoming an issue. Money is not that abundant, and infrastructure costs a lot of money. So at the end of the day, balancing those drivers becomes a big issue. Very brief look at standards. I'm not going to dwell into them. These are the ISO standards that deal with asset management. They have different sections. Excuse me. The different sections there. As I said, this thing you can go through it yourselves. They're limited in terms of helping you put together the solution I'm going to show you, but they give you the framework in terms of all the different components that you have to take into consideration when you're doing a strategic asset management plan on asset management. IWA, International Water Association, got a little bit more involved, and they interpreted main objectives of those standards, and those are there. So we see from those objectives that a lot of aspects in terms of performance have been covered. I'll say something about the strategic asset management plan. Again, I'm not going to start reading all that. It's mainly for reference to have things in perspective. I'll focus a little bit on the next slide in terms of the approach we adopt as a company for asset management. Basically, we developed a procedure for transforming the utility and manual framework for utility asset management practice and the tools the utility needs to carry out effective and sustainable asset management within the framework of the standards. There's 3 stages involved. There's the assessment and strategic planning stage. There's the implementation of asset management practices and the implementation of an evaluation and improvement system. So if we look at asset management practices, again, we have certain components that are quite critical. Managing a project like this is extremely important in terms of change management. In some of the big projects we're doing, for example, we just started this week, Grenada, okay, the whole island of Grenada in the Caribbean, and it's a big project funded by the Germans. And the guy said to me, "This is a game changer." I said to him, "Yes, it's a game changer." And some of the other big projects we're doing, like in Lusaka, they have their HR director being part of the steering committee of the project, because he realized that he's got 1,500 employees, and the lives of those employees are going to be changed. So change management is very important, amongst other things like risk and quality assurance and all that. So institutional strengthening plays a big part in terms of implementing asset management in organization. Sometimes we do have resistance within organizations. So you need to do a decent project. You need commitment right from the top of the organization to get things right. Then it's the information systems, and that's how I'll show you how the puzzle's put together, and there's certain studies that relate to data improvement, and there's certain studies that have to do with planning, like master plans and stuff like that, to be able to put it all together. Now, I'm going to be speaking more about the asset management systems and their integration. As I said, I'll focus today mainly on water, but just to give you an idea on solar, this is the sort of systems we have. Solar development, meter data management system, because you need a lot of data when you're dealing with electricity. It comes on intervals of half a minute or a minute, both from customers and solar parks, and you need a whole system to manage it. You have full asset management, and I'll expand on that. Operations are quite critical. Control centers that you actually control the parks, billing and energy trading. I don't think in the States you're doing open market energy trading yet. You're doing more transactions in terms of what we call forward market contracts. But maybe at some stage it will come in as well. In Europe, it's quite extensive, this energy trading part. MBI, if you look at the asset management part of it, you need a GIS, you need and your data management system, you need maintenance, call centers, field work, the meter data management system, I spoke before. Operations, the control center is critical. The control center itself has to be linked to the market as well, because as the market operates, the DSO, the electricity authority in charge of distribution keeps on sending you demand and instructions to curtail production and so on. And this thing has to work properly in an optimal manner in terms of maximizing your benefits from the market, but at the same time obeying instructions from the operator. So there's a lot of business intelligence we build up in here to be able to do that. And then rehabilitation and planning, business intelligence. So this is a whole suite of software we have for solar energy. We've only implemented all of this in 2 customers, but there seems to be quite a lot of keen interest right now from a lot of European companies. Okay, let's talk water and sanitation. Water and sanitation, and this is where I'm going to spend more time. Again, we have all the type of systems they'll need. I'll show you everything, how it's interlinked, except quality. I'll leave quality out of it, and I'll leave billing out of it. So I'll concentrate on asset management today. And I'll spend the next 7, 8, 9 minutes talking of how the puzzle comes together. And this is, if you go away from this meeting, understanding this cycle, I would say your presence in this meeting will be beneficial to you. Now, everybody understands the components that I'm going to show you here. The confusion is how to put them together and how to make them work together. This is what I'm going to try and show here in terms of steps. Step number 1 is your GIS and your data management system. All right. This is not just a normal GIS system. You need intelligence here. Intelligence that unfortunately traditional GIS systems don't have. And the most prominent one, is S3 with ArcInfo. There's some other big ones people use, like QGIS, which is for free. And in Asia, they use Supermap a lot and so on. But you need intelligence built into it. And we have our own GIS system with built-in intelligence. So as soon as you take data, it sort of evaluates it, gives you all the problems associated with it in terms of zoning, in terms of connectivity, in terms of missing data and all that. So you need something that will help you go out in the field and verify. We usually have two steps in doing it. We have a session called desktop editing when we convert data, where basically the GIS team sits with supervisors of different areas, and the supervisors tell them what's in the ground, so they keep on fixing things. I remember in Swaziland once they found a 92-year-old man, and they brought him in, and this guy knew the network inside out, at least the olden parts. And after you do desktop editing, then you do evaluation again, and that evaluation will help you, will tell you where the gaps are and where the problems are, and you go out in the field then to verify the remaining parts. Okay, from the register, we go to the maintenance management system. You can already set up in the maintenance management system what we call routine maintenance. That's like for pumps, the manufacturer tells you have to inspect this and that. And for this and that. So everything that you know, and it's normal, you have like plant maintenance set it into the maintenance management system. Obviously, it has to come in with a call center. The maintenance management system has to be linked to your financial management system in terms of getting resources, basically in three different areas: stores, to be able to send requisitions and see availability of parts; human resources, to be able to do scheduling of people and see who's available and what he can do and he can't do and what groups; and support services, that's mainly your vehicles and your equipment, in terms of being able to schedule that into your job cards, into your work orders. When we go to customers that don't have this system here has its own. Like, for example, in Grenada, I'm talking Grenada because it's something recent. They have Microsoft Navision here. They have some sort of HR. They don't have anything here. So I said to them, okay, EDAMS will take over and we'll do your maintenance, keep an asset register of all your equipment and your vehicles, and do the maintenance. Okay, so what goes back into the HR, into the financial management system, is your costing for budgeting purposes, at least from maintenance. So there's detailed costings of different types of activities. So when people come to do maintenance, they have to do budgeting. They've got all the information. And the next step is field work management. That's your mobile units, your people out in the fields that are going to do your work orders, inspections, investigations, carry out work. Now, our system goes a lot further than that. It even has the functionality to be able to record logs and metering. So you might be out there reading bulk meters or registering temperatures or whatever, or even quality. It also has predefined templates per industry to do condition assessment, mainly condition assessment of assets above ground, like treatment plants and different components of that. It even has a functionality to do data capture or change the status. Say you're out in the field and you see that there's a valve and it's not on the drawings, because here you see everything. You see the infrastructure on your tablet, and then you make a note here, there's a valve. I found a valve that goes into a temporary file automatically into the GIS, and the guy from the GIS can now accept it to go in the system or not. So you can, in terms of this data validation that I spoke to you about earlier, it can go automatically, come in here when people are out in the field. It's all created in temporary files, and then the GIS people will have to admit it into the main register or not. These people in the field don't have the right to change the asset register just by themselves. Then we have operations. Operations is linked to SCADA, telemetry, or Torre, MI, or whatever you have there. There's all sorts of systems we've linked to through APIs or through whatever. And that's nice because that automatically will enable reactive maintenance in terms of failure. If anything fails, you know about it straight away. It goes automatically into the maintenance system, you give priorities, whatever. The maintenance takes over in terms of addressing the issue. It also has preventive maintenance built in terms of triggers. Say, for example, you're doing vehicles here. Operations will register the mileage of the vehicles, and the vehicles have a certain mileage. There's going to be a trigger there telling maintenance to go and service it. It could be temperatures, it could be pressures, anything to do anything with an asset that's registered in the system. Operations also has a lot of intelligence. It has full production analysis and performance analysis of main components. We have building intelligence in terms of PAM performance evaluation. It will tell you if a PAM is performing correctly or not. It will tell you if it's in the right place as well. And don't laugh, because I can tell you a lot of stories about PAMs being in the wrong place. Production analysis as well of boreholes or treatment plants or whatever. It also takes about meter readings. It converts them into continuous flows and puts them in another system called distribution non-revenue water management system. Then we're talking about your billing. Your billing system, what we do is we link to it. If it's our own system, it's automatic, but many times it's not our own system. What we need out of that billing system is connection location. For example, Granada told me only 80% of the connections they have a position. So I told them they got to get all the positions straight away. It's extremely critical if we're going to do any non-revenue water management. Meter readings are imported into a system we have called CDE, Commercial Data Evaluation. We evaluate those meter readings. So we evaluate a lot of things, validity of connections, meters, readings. We find all sorts of problems. There's 10 different types of problems been identified. And that comes up, this thing comes up with something called a commercial rehabilitation plan. Even in terms of, it even identifies slow meters because it has intelligence in terms of understanding the deterioration trend of recording of the meters. So the system will tell you, yeah, this meter is not recording properly anymore. Now, this is critical, this thing, because, when a lot of people talk about rehabilitation, they'll say, go and change all the meters that are more than 15 years old or something like that. And that's silly, though, because, you might have a lot of meters that are 6 years old and they're not performing properly. And you might have meters that are 17, 18 years old and they're performing very nicely. So you need a system to tell you what's not performing, unless you're very rich and you just want to keep on changing things. So this is the intelligence of this system in everything, to be able to save you costs in terms of doing the right action at the right time. This thing also reduces all the information into consumptions and demand as well. And this system now takes over and it understands zoning. Zoning is automatically generated here. It's not what you tell it is the zones. It will tell you what the zones are in terms of identifies areas that are isolated, bulk meters that are functioning, not functioning, whatever. And then it will do automatic water audit per DMA and per higher level, per water scheme, or whatever is possible. It will also give you guidelines in terms of a leakage detection program, which then goes directly into the maintenance site to be able to schedule. For example, you might go into a utility and they tell you, I've got leakage estimated. By the way, this CDE thing also calculates your commercial losses. It will tell you 7% in this area is commercial losses and so on. And this thing will now take the commercial losses into account and will tell you what the leakage is in terms of the approach we have here is both a top-down approach and a bottom-up approach. So in the system, so you use them both to be able to, the main thing with non-revenue water is to people can tell you on a large scale what is their non-revenue water if they're not lying. Most people are lying, but if they're not lying, but the big trick is now to narrow that down to the point where you can pinpoint it to the last connection, last meter that's wasting your money, or to the place where the thing is leaking. And this is what the system helps you do. So you keep on narrowing down things until you pinpoint things. If I have a good hydraulic analysis guy, he might come up with a question here. I'm going to skip the answer. Right now, all right. This thing also does full demand analysis, which goes into a hydraulic modeling system. And that thing is used for two things. It's used to be able to do upgrading plans, optimizing the operations of your networks. And people underestimate the importance of optimizing what you've got. This optimization is basically you maximize the use of your existing assets. And you should do that rather before doing any expansion on master plans. The other thing it does, it gives you the replacement type and size of your asset, and I'm mainly referring to pipes. So why is that important? It's extremely important because in traditional condition assessment and asset management planning, rehabilitation planning, you'll say, this pipe is corroded, is leaking, I'm going to change it. A big question is, what are you going to change it with? Or give you another question, is that pipe really needed in that place? And my experience over the years, looking at these utilities, I remember when we did Kimberley in South Africa, I've decommissioned, I think about 7-8% of the network of 15-20 kilometers of pipes, and decommissioned them. I said, no, you don't need them. We rezone the system and we just decommission them. So it's very important to do this optimization and see what the network needs in there. And if something has to be replaced, what it should be replaced with. You might have a 300 millimeter pipe and you only need a 100 millimeter pipe there, or vice versa. Your pipe there might be too small and throttling the whole flow of the system. So this is something that is ignored and is a result of a lot of waste of money in terms of rehabilitation. The next step is your asset management planning, or a lot of people understand this module as asset management by itself. This is where you're doing your rehabilitation planning. Now, to do this properly, you need a lot of information that now comes from this system, where it's being reported through all these processes. All these processes have to happen to have information stored in here that will give you the input to do proper rehabilitation planning. And that's the condition of the assets, the maintenance records, even the leakage in the area where the asset is, that plays a role, even the number of complaints you've had from people about the service delivery in that area. There's a lot of different types of information. Replacement type and size coming from here. It's a lot of environmental and town planning data that's critical, especially for doing pipe work. Things like, for example, proximity to rivers or natural resources. Importance, for example, traffic loads in terms of the roads above them that affect both the condition of importance, soil types, corrosiveness in the soils, flood lines in terms of a risk of flooding the area, proximity of water to sewer and vice versa. So there's a lot of information which is imported externally in terms of shape files and takes part in this total, in this both in terms of the condition assessment and importance assessment of each asset. Now, the main output of this thing is, first of all, a proactive or preventive. Some people call it preventive, we call it proactive because we call this preventive. Maintenance plans. It will tell you these assets, you got to watch them closely because they might fail. Go and do an inspection once every month or whatever. A full rehabilitation plan will tell you these assets will have to be replaced or rehabilitated. Now, how does it do that? It does it in terms of doing condition assessment, importance assessment, full risk assessment, and then ranking the assets in terms of the risk. And then based on your budget, give you recommendations. And then you can set up within the system different plans, different action plans. Say for action plan 1, I'm going to do it during this period, and I have this budget for it, and so on. The other thing this thing does is evaluates your assets based on the expected life of the asset that's remaining, and that asset valuation is again stored here, and it's a very important input for the financial people, especially if you want to revise the balance sheets. A lot of people do it for raising funds or for whatever reason. The next step is to link this technical asset register, because at the end of the day, if you look at it, this is your main technical asset register. Now, in the financial asset register, you have to keep information, but usually it's kept in groups. So you can group inventory information from here into here. So you synchronize the technical and the financial asset registers. Whenever we go into a new customer, we try and do the synchronization at the base level, and we never manage to get them to agree. This thing is far away from this thing, and vice versa. But with this system, at least you set at the same basis, and then you do the synchronization, and thereafter things are fully synchronized. These groupings are done in terms of the way the customer wants it. Usually it's split into mechanical, electrical, and civils, and different types of assets that are have the same depreciation period. Also, all sorts of information comes up. Inventory information, valuations, disposals, impairment, all these sorts of fancy things that accountants like to talk about and they put in the balance sheet. They're all grouped and they come up here. Okay, so the next step is your investment in business planning, which we get input from a lot of places. How you say the infrastructure and rehabilitation plan, you're upgrading your master plans, your commercial rehabilitation plan, your maintenance budget. It now comes from budgeting, knowing all the information that comes out of the system, and you do investment in business plan. Now we have a system that does this, but most of the clients still do things by hand here. That investment planning decides on the final plans. It goes what goes into construction, and then from what goes into construction, we have things as built information that will go into the database. The system differentiates between commission and work in progress, because that's very important for accountants. You know, they pay for assets when they put in place, but they only start depreciating them when they're being commissioned. So that sort of information is important to be in. We actually have special templates and guidelines where we give to all our new customers, and we say to them, from now on, when you go on an RFP, you have to give this thing to the consultant, the contractor. So when he hands over his data, he has to also hand it over in this format. It's a very simplified format, but it automates the importation of new works into the system automatically. So you don't need your GIS department to start capturing everything from scratch. It's imported directly. So all our customers have implemented that, and they're extremely happy that things are smooth. Your last part is your business intelligence. Now we have what we call a utility management portal, where it's structured in in a different hierarchy and different areas. You have a section for stakeholders, and there you have dashboards that have to do for stakeholders, and then for senior management, there's different types of dashboards, and it goes all the way down to actual operations, to the guy who's doing the work, who's going to see his dashboard. And you can even drill down to the smallest problem from that, because this whole thing has access to the full database here. It's not just dashboards. You can do graphical type of reports and queries or other types of reports. So this is how we managed over the years, our experience over the years. I think this is what it resulted in, putting this puzzle together. And this is an area where I would really welcome comments. Okay. I'm not going to be long now. I'm going to be finished in 2-3 minutes. I'm just going to show you the equivalent diagram for municipalities. Without discussing it, it's much simpler, but it's similar. For water utilities, it can get quite a lot more complex, like I showed you. That's why I chose to show you that. But this is municipalities. We have industry-specific asset registers for all these. What does that mean? It means that industry-specific asset register means that the system understands that this is a pipe. It's not a line. And what type of pipe it is. Understands this is a house, this is a car. And that built-in intelligence the system has, we associate with functionality in terms of what that asset should be doing and what it's doing. So that's what an industry-specific asset register means. So we basically cover all the municipal type of assets. And this is your generic asset management system and how it's put together. Case studies very quickly. This shows some main customers. This is all the international organizations we did business with. Just about everybody, was anybody. A lot with USAID, a lot with the Germans, a lot with the World Bank. We just signed an agreement with Bill and Melinda Gates Foundation recently, because they spend a lot of money into on-site sanitation, developing countries, and they wanted us to rearrange EDAMs for these people to be able to manage it. They've already told us to start with Lusaka and Lagos and a few other countries. With the Germans, we actually have an agreement on the highest level with the German government, a strategic alliance agreement. I think we're the only non-German company ever to have achieved that. They did it because they did research to see if they could find a decent asset management company for water utilities. And the Germans spend a lot of money in these 6 countries that are going to enter Europe. So they wanted us to go in and help these utilities improve their asset management capabilities, so the Germans could justify the investments they're doing in these countries. They regard it as a very successful project. It's called CM. It's got its own website. You can look it up. A couple of 100 utilities joined in, about 200 and something. This is a nice little, in Egypt, we do a lot of work. We control most of Egypt. This is a nice little link to YouTube if you want to go. It's being released this week by Beni Suef government, and they talk about what they've achieved, both in terms of asset management. They also talk about billing and quality, because there we put all our systems in, but they're very proud of themselves. You can click on the link and have a look. Benefits, I'm not going to go through them. You can read them yourselves. This is quick wins that you have when you implement asset management, and this is more medium to long term.